everyone, I hope all of you are doing good. I am Roshni from Learner Hub, the free learning platform, and today I am here with a video on combustion and flame class 8 science. So this is the first video of this video series, and in this video we are going to learn about what is combustion, what is a fuel, what are combustible substances, right? Now where have we seen this process of combustion? Actually in a lot of places. Now when you burn a piece of paper, that's combustion. When you burn a log of wood to produce fire, that's combustion. Not just that, when you see a burning candle or a burning diya, that's combustion again. The gas stove burning which helps you to cook food, combustion again. So basically what we call as burning in day-to-day life is actually combustion. And we see that in the process of combustion, a lot of energy is released in the form of heat and light. So in today's video, our agenda is to understand the entire process of combustion and how does it produce so much of heat and light. So let's get started. So let us start with what is combustion. So it is a process in which a substance reacts with oxygen to release heat and light, and that is what we actually see as flame or fire in different substances. Now what happens when you light a candle? You see the fire, right? So because of that fire, even if you try to light a candle in a dark room, what happens? When the candle is lit, the fire actually gives light to the entire room. So it actually releases light. And at the same time, if you try to take your finger near the flame of the candle, you feel hot. Why? Because heat is also released during the process of combustion. So you can think combustion as the process of burning. But how do we define this process scientifically? Because what exactly is happening inside that so much of heat and light is being produced? Now basically all that is happening is the substance is reacting with oxygen. Now this is very crucial. Combustion can take place only when oxygen is present in the surroundings. If there is no oxygen, there will be no combustion, there will be no burning. So this is basically combustion. Now when you talk about a release of heat and light, now it is not necessary that light has to be released during combustion of all the substances. Light may be released, light may not be released. Now if light is released, light can be released in the form of a flame, light can be released in the form of glow. For example, if you try to compare the process of combustion in a candle and coal, so here you see coal, and here you see candle. Now in both the cases, if you burn both of them, so what I am trying to explain is, if I burn both of these, the process that is taking place is combustion, because as soon as I burn it, the substance, that is the coal or the wax of the candle, it is reacting with the oxygen of the surroundings, and due to that reaction a lot of heat and a lot of light is being produced. Now if you compare these two scenarios, in this scenario you see, you really do not get a fire or you really do not see a flame in case of coal. But what do you see? You can see a reddish glow on the coal. That happens due to combustion. Whereas in case of candle, you can very distinctly see the presence of this flame. Now so it depends how light gets emitted in different substances. It depends from one substance to another. Now again, it is not also important that all substances will burn to release heat. So we can say that not all substances undergo combustion. You take example of matchstick. So do you think that the matchstick undergoes combustion? Yes, it does. Now why I took this example was, since I was talking about substances which do not undergo combustion, so that was just to confuse you. But yes, matchsticks undergo combustion, because you see, what do you actually need to do so that the matchstick catches fire? All you need to do is you have to rub it or you have to strike it against the side of the matchbox. So when you strike it, there is friction. When there is friction, there is heat, and the matchstick ignites. Now once it ignites, you can see the flame, so light is released, heat is also released, and you can feel that if you take your finger near the matchstick, near the burning matchstick. So that way matchstick undergoes combustion. Now let us look at some examples of combustible substances. Now what are combustible substances? Those substances which undergo combustion, that is, they burn easily to release heat and sometimes light. So just now I was telling you, right, that not all substances can undergo, or not all substances can burn to release heat. So those substances which can burn to release heat, they are called combustible substances, and examples are all these which you see on the screen. For example, paper. So if you see paper, do you think that paper burns easily? So just bring a matchstick near the paper and you see that immediately it catches fire. So paper is combustible. You take example of a matchstick. Again, it is combustible. It easily catches fire. You take example of diesel, petrol, kerosene. You take all these examples and you see that they very easily catch fire. That is why you would have seen that in the petrol pumps, people are not allowed to smoke. Why? Because the chances are very high that if in case somebody leaves a burning cigarette or a matchstick there, so the chances of petrol catching fire is very high. So that's why it is not allowed. You take examples of paints, you take example of magnesium or aluminium powder. Now most of the metals as such, like if you take example of iron or any metal as such, they are non-combustible. They do not undergo burn, they do not burn to release heat. But some metals in their powdered form, for example aluminium powder or magnesium powder, so all these powdered form of metals, they are combustible. That is, they get burned to release heat. So these are all examples of combustible substances. Of course, not to forget wood, coal, they are also combustible substance. Now it is just that all these combustible substances, they undergo the process of combustion in different ways. Some of them will produce huge fire, some of them will produce flames, some of them will just show some sort of glow. So that varies from substance to substance. On the other hand, we have a set of non-combustible substances which do not undergo combustion to release energy. So they will not get burned to release energy. Let us look at some examples. Most of the metals are non-combustible. So if you take a piece of iron, just take for an example, you take iron nail. So if you take this iron nail and put it, even if you put it on fire, do you see that the nail burns? Nothing happens to the nail. The nail doesn't readily burn, so it doesn't burn easily. So that is why it is non-combustible. Similarly, you take examples of glass. Glasses also do not burn. Take examples of say steel. So steel also contain a metal. So steel also doesn't burn. You take examples of stones, rocks. So they are all examples of non-combustible substances. You think of any of these substance and you will be able to find that they do not burn easily to release heat. So that is why they are categorized as non-combustible substances. So now that we are talking about substances which undergo combustion and those which do not undergo combustion. Now did one thing strike your mind? The combustible substances which we are talking about, what are they? They are substances which are being burned, during which they are reacting with oxygen and they are releasing a lot of heat and light. So basically they are producing a lot of energy in the form of heat. So they are nothing but fuel. They are acting as fuel. So fuels are nothing but combustible substances which release enough heat energy to be used for domestic and industrial purposes. So basically any fuel, what is a fuel? what kind of examples comes to your mind when you think of a fuel? You think of coal, you think of petroleum, you think of natural gas. These are all examples of fuels for you. Petrol, diesel, these are all fuels. Why are they fuels? Because they are capable of generating huge energy. How do they generate that energy? By the process of combustion. Only when they react with oxygen, they are able to release a lot of energy, and that energy is released in the form of heat, and this process is combustion. So basically fuels are nothing but the combustible substances, but at the same time not all combustible substances are fuels. Only those combustible substances which release sufficient amount of energy so that that energy can be utilized for different purposes. For example, the energy that is generated by burning coal is utilized in several thermal plants to generate electricity, right? Similarly, the energy that is generated out of petroleum, whether it is petrol or diesel, so that is used to run vehicles. So that means the energy is huge enough to be used for different purposes. So that those kind of combustible substances are fuels. Let us look at some examples of fuel. So first example is coal. So we can even look at some other examples like petroleum, wherein you have petrol, diesel. These are also examples of fuel. You have example of the LPG, which are just put inside your cylinder. So this also generates sufficient heat energy, which helps in our domestic purpose of cooking. Natural gas, biogas, or cow dung cakes. In fact, in villages and rural areas, you would have seen that they really do not use LPG gas cylinders and all. They often use the cow dung cakes, and with that they try to prepare food. So cow dung cakes, however, there are a lot of disadvantages associated with the usage of cow dung cakes, because they produce a lot of pollution, they produce a lot of smoke, which is disadvantageous to the health of the women preparing food. But yes, they are still considered as good fuels because they generate a lot of energy. Wood is another example of fuel. So when you burn wood, the energy generated is huge enough that you can actually prepare food. So it can actually boil things. So that much heat energy is generated during the process. Now, when we talk about a fuel, what do you think defines a good fuel? How do we know which is a good fuel and which is not? Because just now I gave you so many examples. I told that cow dung cakes are also fuel, but they are not preferred to be used because they cause pollution, because they adversely affect the health of the women. Now, so in a similar way, what are those characteristics which defines whether a fuel is a good fuel or a bad fuel? So let us quickly look at the characteristics of a good fuel. First of all, it should be easily available. Now, if that fuel is not available, then there is no point, because the fuel is not accessible, so we cannot use it. So even though it has a lot of properties, but that doesn't make any sense. It has to be cheap. If it is very expensive, then a lot of people will not be able to use it. So it has to be extremely economical. Burns easily to release heat, because a fuel is something which generates energy. In order to generate energy, it has to react with oxygen. Now, the easier it reacts with oxygen, the better it is, because it immediately reacts with oxygen and a lot of energy is released. So that energy release is the most important thing, is the basic definition of a fuel. So it should burn very easily and it should release a large amount of heat. So the larger the amount of heat it produces, the larger energy it produces, and then that huge energy can be utilized for different domestic purposes or industrial purposes. Does not leave undesirable residues behind to cause pollution. Now, this is very, very important when we decide which is a good fuel and which is not. Now, most of the fuels, in fact, a lot of fuels, they generate a lot of energy in the form of heat, but at the same time, they also produce a lot of harmful gases. They generate a lot of smoke, they leave a lot of residue after being burnt. Now, even if you completely burn a particular substance, you see that, for example, when you burn paper, what is left behind? You have ashes left behind. So now that is called residue. So whatever is left behind after complete combustion of that substance, that is called residue. So any fuel which leaves behind a lot of residue, so what happens to that residue? That residue, if it is something which is harmful, then that is waste to our environment, because it is just using that fuel is actually piling up those waste materials in the environment. So while deciding whether a fuel is good or not, it is very important to check the type of residue that is being left after the process of combustion is over. And a good fuel is one which does not leave a lot of undesirable residue, so that it doesn't cause environmental pollution. Now it is very important to see that the fuel which we are categorizing as a good fuel is good for the environment, because if it is harming our environment, then basically there is no point in generating energy from such a fuel, which in turn is causing harm to the environment and is causing harm to us. But now the question is, how do we know which fuel produces how much energy? So we looked at all the characteristics of fuel, and we said that a good fuel is one which generates more amount of energy. But how do we know which is generating how much energy? How do we calculate, or how do we measure the amount of energy that is produced by a fuel? For that was introduced calorific value of a fuel. So calorific value tells us, or it defines the amount of energy that is produced by a fuel. Fuel is nothing but a substance which on burning produces energy. So calorific value of a fuel is the amount of heat energy that is produced on complete combustion of 1 kg of a fuel. So that's what we want, that we take a fuel, we just burn it. During burning, it will undergo reaction with oxygen, and as a result of this reaction, a lot of energy will be released in the form of heat. So that amount of energy which is produced when 1 kg of a fuel is burned completely, that is defined as calorific value. So now we have one particular standard to compare the energy productivity of various fuels. So higher the calorific value of a fuel, higher is the heat energy produced by that fuel. So better the fuel is. So for a good fuel, its calorific value should be higher. And the unit in which it is measured is kilojoule per kg. Why kilojoule per kg? Joule is the unit of energy, right? And kg is the unit of mass. So the amount of fuel that is being burned to produce energy in terms of joules. So therefore the unit is kilojoules per kg. So let us look at the calorific values of various fuels. For example, when you talk about coal, so what would be the calorific value of coal? It is somewhere around 25,000 to 33,000 kilojoules per kg. So that is the calorific value of coal. So that means 1 kg of coal, if completely burned, will produce 25,000 to 33,000 kilojoules of heat energy. You think of petrol. So in case of petrol, it is 45,000 kilojoules per kg. You talk about LPG. So in case of LPG, the value is 55,000 kilojoules per kg. So you see, now since we have a specific value, so it becomes very easier to decide which is a better fuel in terms of the amount of energy produced. So out of these three, the highest calorific value is that of LPG. So therefore LPG is a better fuel than petrol or coal in terms of calorific value. You take examples of biogas. So this biogas is formed from the remains of dead plants and animals. So biogas has a calorific value of around 35,000 to 40,000 kilojoules per kg. You think of wood. So wood has a calorific value of 17,000 to 22,000 kilojoules per kg. So if you compare all these values, you see the minimum calorific value is that of wood and the maximum calorific value is that of LPG. So if I ask you that in terms of the amount of energy produced, which is a better fuel out of these 5 fuels? So the best fuel would be LPG, and the worst one out of these five would be wood. So that's how calorific value helped us to decide the heat productivity of a fuel.
I hope you found the video useful. If at all you have a feedback to share, do let us know in the comment section. And if you liked the video, do not forget to share it with your friends. I will meet you all very soon with a new topic, with a new video. Till then, take care. Bye-bye.